For topic 2, we're going to determine whether a number is a solution to an equation. So I should probably have added to an equation, but I didn't, so here it is. So topic 2, we're just going to check to see if some value really is the solution to the equation. The solution to an equation being the value for the variable that makes the equation true, okay? So we have that right here. Sometimes you'll see that the solution is the value for the variable that satisfies the equation. That just means makes the equation true, okay? So what you do is you take whatever value you were presented with, you plug it into, oh, my dog just came in. You take whatever the value for the variable is that's been given to you, you plug it into the equation. So you kind of evaluate the entire equation for that particular value. And then if you're left with a true statement, that value is the solution. If you get a false statement, that value is not the solution. Okay? So let's look here. For example 2, the directions say determine if the given value is the solution to the equation. Okay, now when you have these linear equations in one variable like this, there's really only going to be one solution. There's kind of like a special situation that we'll talk about maybe I think in the next section. It might be later in this section, I can't remember. But there is kind of a catch to that. But generally speaking, when you have a linear equation in one variable, there's only one solution. Okay, so it's pretty easy to check to see if a particular value is or is not the solution. Okay, so for part A, it says determine if 4 is the solution to 3 times parentheses x minus 6 equals 6. Okay, so we're just going to rewrite the equation. Whoops. Get away from my highlighter. So we're going to rewrite the equation, but anywhere we see an x, we're going to replace it with a 4. Okay, so we get 3 times parentheses 4, that's x, minus 6 equals 6. Okay. And then we want to figure out what 4 minus 6 is. Well, 4 minus 6 is negative 2. So we get 3 times negative 2 equals 6. And then finally, on the left, we have 3 times negative 2, which is negative 6. So then the question is, does negative 6 equal positive 6? And the answer to that is no. This is a false statement. If 4 were the solution to this equation, we would get something true down here at the end. We would have gotten like negative 6 equals negative 6 or positive 6 equals positive 6, but negative 6 does not equal positive 6. So we would have to say no. 4 is not the solution. I put a dash there. That looks like I'm saying negative. Let me fix that. So I'm going to put no, 4, maybe a period. We'll have to ask the English teacher about my grammar. But no, 4 is not the solution to the equation. Okay, so let's look at part B. Part B says determine if negative 2 is the solution to 4x minus 3 equals 5. So again, we're going to rewrite the whole equation, but anywhere we see an x, we're going to replace it with a negative 2. Okay, so negative 4 times x, which is negative 2, and I'm just going to use parentheses to replace the x with a negative 2. It kind of keeps the negative with the 2, and it indicates multiplication. Okay, and then we're going to say minus 3 equals 5. So negative 4 times negative 2 would be positive 8. So I get 8 minus 3 equals 5. And then on the left, we still need to take care of 8 minus 3. What is 8 minus 3? Well, 8 minus 3 is 5. So in this case, we have a true statement, okay? 5 really does equal 5. So in this case, we can say that negative 2 is the solution because negative 2 is the value for the variable that made this a true statement. So we would say yes, again, my dashes, yes, negative 2 is the solution. All right, so it's that simple. Now, I did give you fairly easy examples right here. You could certainly have an equation that looks more like this up here, okay? And if you were checking to determine what the solution is here, you would just have to plug in whatever value for z into every single term that has a z. So you'd have to just plug that value for z in more times, but it's the same process, okay? So again, down here for example 2, the examples were pretty easy. Okay, you only had to plug the value for the variable in once, but the same process applies regardless of what the equation is. Okay, so in the next video, we will start kind of building the process to solving linear equations in one variable.